Lock mechanism is based on a simple 5-link mechanism. An additional double parallelogram mechanism keeps the foot angle constant to the body. A special differential mechanism is employed for neck and tail. Angle combination of two arms on the body side determines the posture of whole limb. Unlike usual biped robots, leg of Titus 3 is locking in a pair of joints at hip and ankle. Those are used to move center of gravity laterally onto the foot of supporting leg to stand. In case of Titus 3, its neck and tail can substitute this fraction. Because the mass is distributed on the neck and tail, by changing posture it can control the position of the center of gravity in the lateral direction, and then it can walk statically. On dynamic walk or faster walk, the swinging pattern of neck and tail is changed from the completely static one. That is because inertial force comes to be more dominant factor than the position of the center of gravity in its stabilization. In spite of limited degrees of freedom, by combining motion of whole limbs, Titus 3 can perform dynamic turning motion successfully. Development of this model is not intended for
increasing the leg lift height.
$20 worth of parts aside from the Arduino. Now do you want to put on a little show? Alright, robot. I want you to stand up tall for me. Ah, big stretch. Good job. Can you crouch? Oh, of course you can crouch. Do you want to stand up now? Oh, come on. Yes, you do. Okay. Nice job, little robot. Alright, what else can you do? Can you do something fun for me? Like dance? Nice. Good job, robot. So, can you run yet? No, but will you be able to run soon once I actually code you? Yes. Alright, clever robot. Thank you, Cat. Also a very clever creature. So yeah, this is just built with an Arduino and popsicle sticks and 6 little Tower Pro SG90 servos, each of which cost about $3. So yeah, in total, one of the cheapest little robots you can possibly build. Thank you for watching and have an excellent day.